Hey, good morning, everyone. I'm guessing a bunch of you are here just to see if I really think reflection is evil or if it's just a clickbait title. So let's go find out. And if the clicker worked, that would be even better. There we go. All right, so just a quick recap. What is reflection? The ability of a running software application to inspect, modify, and dynamically invoke its own components at runtime. Okay, I'm just going to use this because the clicker is not working consistently. So why do people use reflection? These are just the most common use cases. There's many more use cases than this. But if we look at it, there's some very common ones. So dynamic class loading and instantiation. We see a lot of these. People use it for serialization, ORMs, object relational mapping, dependency injection, etc. Then there is developer workflows. Using it to create test frameworks, right? Being able to call into something in your code that's actually private, but I want to be able to test it, so use it there. Then take that to the next level by using mocking libraries to really build alternatives to the real implementation. Debugging, I need to figure out what the heck is this class is at runtime while I'm stepping through the debugger. And of course, most famously, workarounds. I'm using this old version of this library. The method was private in that version. Let me just call it in there, right? Very common way of using reflection. Now, of course, reflection has some downsides. There's performance costs, right? You have to do these dynamic lookups that takes time through the reflection APIs. The compiler, JVM compiler, can do fewer optimizations, less inlining, etc. You lose type safety. Like instead of getting nice compiler errors, you now hopefully get runtime errors. There have been some serious security issues, mainly around serialization, where somehow you can find a path to trick the runtime to instantiate a process object, and now you can execute any arbitrary binary on the system. And then, of course, there's maintainability issues. Your code becomes more complex because you need to read through all these reflection calls. Your debugging becomes more complex because all of a sudden random things are being instantiated at the runtime. And then there's tooling issues. Your refactoring logic in the IDE doesn't know about your dynamic calls to this code. Static analysis cannot prove that something is called. When you do find all usages, it doesn't show up all the call slides, right? So there's definitely some concerns using reflection. Now, how do we get here? And this image, of course, Gemini generated for me. Way back, we started programming using physical switches. Then punch cards came along. Then the first programming languages, assembly languages came along. But really, until like the late 90s, when somebody wrote a piece of software, they wrote it all. And it wasn't really until the early 2000s that we started relying on more and more third-party libraries. Of course, now with GitHub, Maven, like everybody uses third-party libraries for everything. And so why can this be problematic? So let's take a look at a case study. Bouncy Castle is a very common used library on JVM to do encryption, crypto, hashing, etc. It's a great library for that. It comes with almost any crypto algorithm that you want to use. The downside is that in their code, if you want to get a specific algorithm, they use some way of building a string and then find the class and load that implementation. It's great for dynamically figuring out which algorithm we want to swap in. The downside is, if we look on Android at which apps have a lot of code that is not optimized, Bouncy Castle is one of the worst performing ones. Well, of course, Google shows up here, and that can be all separate lightning talk about that, what we're doing to fix that. What we're fixing that. Now, why is this a problem? If you look at the ProGuard keep rules for this library on Android, it has over 240 lines that all say, keep this class and keep all public methods, even if you're not using it for that specific app. And so now your app gets bloated with a lot of different code. I remember from the keynote, I mentioned apps that turn on R8 see all these benefits. Why don't they? Because it's hard. Because you turn on R8, it says, oh, this code is not used. Let me remove it. And then you end up with all these weird runtime crashes. And people decide, well, I'm not going to turn on R8. It's too hard. Now, why do I think reflection is evil? And these are my opinions. These are not Google's opinions. I mean, after all, Google gave you such beauties as JUICE and JSON. So these are pure my opinions. So dynamic class loading, I think these are evil. There's many better solutions, right? Like you randomly end up with some instance of a class or even method calls. I think there's much better solutions there. So I'd say pure evil for this use case. There's a couple exceptions. So in serialization, even Kotlin serialization, which does compiler-based generation, sometimes they have to fall back on reflection, especially when there is like these arrays of objects. They just don't know at compile time. But luckily there they can do as minimal reflection as possible that we can still do whole program optimization. Now let's look at developer workflow. I think there it's a bit of a mixed bag. I think testing frameworks is evil because what we often see in Android, people say, well, I cannot optimize my app because now all my methods are going to be called A, B, and I cannot test them anymore because I use reflection to call into private code or even public methods that get renamed. I think you should add a different level of testing, right? At least at a minimum of, if you're testing your production app, to at a minimum do UI testing. But it would be better if you abstract your code that you can still call it in a safe way. Mocking libraries, I have a personal aversion to mocking libraries. I think if you're using mocking libraries, you're not testing your actual app. Like people build more and more abstractions with mocking libraries that I always wonder if they're actually still testing what they want to test. Now, sometimes it's the only option you have. That's probably the case if the library you're using was not designed well, and then you have no way out, right? So sometimes you have to revert to it. I absolutely love using debugging, using reflection for debugging, especially in the IDE when you want to set a conditional breakpoint. It uses the expression evaluator, generates code on the fly. That's usually slow. What I often end up doing is like I create an if statement saying, hey, if get class, if it's this class in this hierarchy, and then inside the if statement, I use just a simple print line and set a breakpoint on that. A lot faster, a lot more powerful. So absolutely good use of reflection. Now lastly, workarounds. I think that's a case of see no evil, hear no evil. You have to do it, right? You're using that old version of the library, old version of OS, that functionality was not available. Sometimes you just have to do it. And in Android X, we have to do this all the time too. So that's, I think, completely fine area to use reflection. So how did we get here? Well, it's one of those classic cases. If only tool you have is a hammer, everything looks like a nail. So last section of this talk, I want to focus on showing you some other tools that you could put in your toolbox. Now, all of these have some pros and some cons, and so you should really think about when to use which tool. First, I think Kotlin symbol or Java annotation processors is a great sweet spot for many tools. It's build time, you generate readable sources. Of course, the downside, you can only add, you cannot modify existing sources, and these processors only act on the API hierarchy. Next, code generators. You have some definition, hopefully simple in a text file, YAML file. Process that and generate some source code. The downside is it's hopefully not a Turing-complete language, so there's only so much you can express. Next, a really powerful bytecode rewriting. You can basically do any changes you want. It's at the compile time, so it's safe at runtime. The downside is you need to be compiler engineer to write these. And it's kind of a black box to users. Similarly, Kotlin compiler has this amazing thing called compiler plugins. It allows you to modify the AST during compilation time, and you get IDE integration, everything for free. Again, you need to be a compiler writer to do these, and the Kotlin compiler API is not a stable API, so you have to deal with breaking changes from version to version. Similarly, JVM TI, it's really there for debugging, but people now use it at runtime too. It allows you to change code as it gets loaded at runtime. It's very powerful, even more or less discoverable for users. And because it runs at the VM level, you have to write it in native code. You cannot write it in managed code. So let's look at some more of these. A lot of people these days do domain-specific language, and they're really falling into two categories. There's external domain-specific language. They have a lot of control. You're basically writing your own language, right? The downside is you're writing your own language. It's quite hard, right? Like, how do you deal with versioning, compile time optimizations? The IDE doesn't know about this language, so there's some cons there. Next, Kotlin has embedded DSLs, and so you don't have to write your own parsers, compilers, tooling. It's a bit less expensive, and sometimes less equal, but it's a really nice sweet spot. Lastly, you can work on a new language feature. Very tunable, standardized for everybody. Downside is it takes quite long, right? The language feature takes several years to implement, and it's probably not warranted for every task. But for some things like what we did with Compose, it makes sense, right? And that's partly a new language feature first, partly a compiler plugin, but it's worth it. And lastly, why not use a good library, right? Integrates with all your existing tools and libraries. Downside, it's a bit more verbose to use. So, with that, is reflection evil? It's really up to you to decide. It's probably more how it's used, if it's evil or not. The library itself, the reflection itself, obviously not evil, but there's definitely evil usage of it. You can see on the skill how I think about it, but I'll leave it up to you to decide if it's really evil. And with that, I'd like to thank you.